When a physical system relies on unchecked probabilities, a single sensor error can ruin an entire production line. Enterprise engineering repeats this exact error when deploying AI for compliance workflows. The anti-pattern is simple, tasking a single vision model or LLM to read data, interpret legal regulations, and issue a final verdict. This flowchart illustrates an LLM attempting to act as a judge. Strict statutory compliance requires absolute determinism. Probabilistic models guess based on training weights. They do not calculate fixed rules. Because of this, model hallucination or statistical drift silently translates into permanent, unauditable policy drift. The Label Lens project attempts to solve this problem. Its primary engineering challenge is processing complex regulatory label data within a strict 5-second operational ceiling. To hit that target reliably, Label Lens operates on a strict doctrine. AI is restricted entirely to extracting evidence. Deterministic software rules evaluate that evidence. Human reviewers retain absolute authority over the final disposition. Intellectually, the doctrine is sound. However, stating an intention in architecture documentation offers zero protection against production realities. True architectural defensibility in AI systems requires explicit physical boundaries enforced by types, code packages, and state machines. Architectural Decision Record 0002 addresses this by mandating a physical severing of the extraction process from the regulatory evaluation process. This diagram maps out 3 completely isolated domains: probabilistic extraction, deterministic evaluation, and human disposition. The extraction lane's API contract returns only raw text and confidence scores. The backend firewall physically rejects any payload carrying regulatory compliance statuses across the boundary. But securing the backend solves only half the problem. A front-end user interface can easily undermine a secured backend if it uses the wrong language. The pipeline documentation conflates machine-generated verification findings with final human decisions. This dashboard mockup highlights the danger of using vocabulary like pass or fail to display backend machine states. Users interpret those words as final agency approvals, which is why they must be replaced by precise semantic tags like observed match and insufficient evidence. Implementing this exact vocabulary ensures the interface accurately reflects the system's strict role. It is an evidence gatherer, not a decision maker. If semantic boundaries aren't rigidly enforced in both the data schema and the user interface, the separation of AI and human authority fails in practice. Even a highly principled, local-first OCR architecture will fail when fed low-quality source images. ADR 0005 addresses this constraint by requiring a cost-aware, bounded OpenAI vision fallback to prevent reviewers from hitting workflow bottlenecks. This state machine defines the path for escalation. Triggers are evidence-based, relying on hard thresholds like missing fields. To prevent infinite, costly cloud API retry loops, we derive a canonical evidence identity, combining image hashes and versions to lock the state machine. This unique fingerprint guarantees that the exact same piece of evidence running on the same pipeline version will never trigger a duplicate fallback call. This creates a direct latency contradiction. Waiting for a synchronous CloudVision API response violates the system's mandatory 5-second performance ceiling. Resolving this requires shifting the architecture to support asynchronous pipeline states and progressive UI reporting. In practice, an initial local result flags as needs review. This allows the human agent to process other tasks seamlessly, while enhanced cloud evidence arrives asynchronously in the background. Relying on cloud AI fallback is viable only when the system's state machine and user experience are explicitly designed to tolerate asynchronous latency. The overarching doctrine of the system dictates that total operational cost and reliable task completion matter significantly more than minimizing isolated compute costs. A cheap AI model that frequently stalls, fails silently, or requires extensive manual agent intervention rapidly becomes a costly modernization burden. This view of the repository documentation shows an accepted governing policy artifact abruptly truncated mid-sentence. This is not a stylistic typo. It exposes a severe gap in the repository's documentation integrity gates. When a value statement lacks measurable criteria, the concept of operator trust can be twisted to justify careless over-automation or complete manual regression. Empty prose must be replaced with hard engineering metrics, maximum acceptable interruption rates, explicit timeout recovery behaviors, and strict limits on manual reentry. An unmeasurable architectural policy is functionally equivalent to having no policy at all. The current architectural design of LabelLens boasts immense breadth, detailing versioned rules, batch isolation, and complex workflow coaches. This diagram illustrates the immense theoretical weight of that infrastructure. This exposes the architectural drift risk. The repository is becoming documentation complete before it is evidence complete. Expanding theoretical layers offers diminishing returns until the absolute simplest capability is proven to work. ADR 0009 introduces an explicit constraint to halt this drift. It demands a minimum viable vertical slice before any further design expansion occurs. Step 1 requires pushing exactly one uploaded image through one real extraction provider to generate a small, strictly typed evidence object. Step 2 feeds that single evidence object into exactly 3 deterministic rules, such as an exact heading validation and a numeric ABV comparison. The final step requires the system to generate one explainable report within the measured runtime, fully supporting a human reviewer's correction. Ultimately, testing actual code under operational load is the only true mechanism that consistently separates viable engineering from theoretical fiction. Exceptional architecture documentation can easily obscure whether a system actually works. The only faithful next step is to write the code that makes these principles falsifiable.